Hi, and welcome to the Community App Intro tutorial. The purpose of this video is to introduce some OSK features that are common to all the community apps. My goal for each community app video is to keep it focused in under 10 minutes. Here are some of the important OSK directories that will be used in the community app videos. OSK has 3 top-level directories corresponding to its 3 components. Cosmos has an architectural concept called targets. Targets are used to define remote systems that communicate through a Cosmos interface. Each flight software app is defined as a Cosmos target. OSK has 2 targets that are not associated with an interface. The first is CFS_Kit that defines screens and Ruby scripts that have a system scope. CFS_Kit was OSK's original name. A second virtual target is SimSat, and this defines screens and Ruby scripts for OSK's reference mission. The Cosmos/config/tools table manager directory contains text files that define the structure of flight software binary data files. The Cosmos CFS_Kit directory, not to be confused with the CFS_Kit target, contains a file server directory that is used for transferring files to and from the flight software. It has a subdirectory called tables that is used for table transfers. The Cosmos/lib directory has OSK extensions to Cosmos. You don't need to know the details of the extensions when you're working with OSK screens. You will need to know some details when you're writing scripts. At the time of this video, the code and demo scripts serve as the documentation. OSK has not changed the default CFS directory structure. There's an apps directory that contains a directory for each app. For the community app tutorials, the important directories are the docs directory that has the app's user's guide, the flight software/platform include directory that has most of the configuration parameters, and the tables directory. In the app tutorials, I'll demonstrate how configuration parameters and tables can be used to tailor apps for your needs. The CF directory structure is created during the CFS build process. Therefore, when you first install OSK, the directories below CF do not exist. When you run OSK demo and test scripts, they check to make sure any required directories exist and create them if needed. The CF directory contains the CFE startup script, apt object files, and default table files. There are currently 3 OSK directories in the CF directory. The demo directory is used for demos, and subdirectories are created and deleted as needed. The SimSat directory is used by the reference SimSat mission. The base directory is a general purpose area, and the rec directory is an example recorder. If an app demo needs files to be opened or automatically generated, then the Instrument Simulator or iSim app is a convenient way to produce science files in a recorder directory. The test directory is used for integration and functional test. OSK does not cheat by simply sharing a directory between the flight and ground. The Trivial File Transport Protocol app, or TFTP, is used to transfer files between the flight and ground systems. Starting with OSK version 2.5, the CCSDS File Delivery Protocol app, or CFDP, is included with the kit. However, at the time of this recording, it has not replaced TFTP as a default transfer app. Different ground tools are used to view flight software files. The text file viewer generically refers to any tool that can view a text file. The Cosmos Table Manager is used to view most binary files. It is not suited for binary files with variable length records. The CFE file viewer is used to view files that aren't suitable for Table Manager. Custom code needs to be written for each file. OSK comes pre-installed with the SimSat reference mission apps. There are additional apps in the kit, but they are not built with the CFS nor loaded during CFS initialization. The SimSat apps are grouped into functional groups. Each group has a screen that follows the same layout. The app diagram highlights the particular app group being viewed. For each app in a group, there are menus to access the complete app interface, including commands, telemetry, and user's guide. And if applicable, there's a display table and a display file button. Display table dumps the table, transfers it to the ground, and uses the Cosmos Table Manager to display the table. Display file is very similar, except it issues the command that generates the binary file as opposed to a table dump command. Under Learning Resources, you can access the YouTube videos, screen-based demos, script-based demos, and documentation. A single slide deck will contain the slides used in each of the app videos for a particular app group. The Function Screen section provides quick links to screens that are relevant to the app group. These screens often involve more than one app Only include commonly used commands and display the most commonly used. Here's the Cosmos command and telemetry server that is automatically started when OSK is launched. In the Targets tab, we can see all of the flight software apps defined as targets. The prototype benchmark app is an example of an app included in OSK but not built or started. If we scroll down, we can see CFS_kit, and it has no associated interface. In the Command Packets tab, we see a list of all the commands, and the Command and Telemetry server provides a quick link to the command sender. Likewise, in the Telemetry Packets tab, we see all the telemetry packets, and it provides a quick link to Packet Viewer. The OSK app group pages provide these functions, plus additional functions, and more importantly, they are logically grouped to provide functional context. Let's use data storage as an example. If we want to send a command without parameters, it will just immediately send it. If it's a command with parameters, such as set app state, it will prompt us for the appropriate command parameters. And also it loaded the default as the default parameter. For telemetry, we actually do use the packet viewer. So if I do display telemetry for file info, it's going to launch packet viewer with the file info packet. And we can still access all of the telemetry packets for a particular app using packet viewer. As mentioned, for display table, it's actually going to walk us through the sequence. So the first when I clicked it, it immediately dumped the table. Now it's asking us if we'd like to transfer the table. And we can see that TFTP was used to transfer the file. Now we're given instructions for how to use Table Manager to actually view this file. So we're going to go, it opens the Table Manager. We're going to the file server. As I mentioned, the tables are in a subdirectory. It's a temporary file that was used. And we also dumped the file table, DS file table. So I'm going to alphabetically sort these. Go to DS. And then we can use the file table, and that's just the text file that's going to decode it. So now we can see that it's properly decoded with the file. So now we can close these. And similarly, the data storage does not have a command that creates a binary file, but FM does, File Manager. So if we wanted to list a directory listing, we would do the same process here with display file. And finally, we can access each of the user's guide from here, which is a very convenient way if you want to look up anything to do with the app. Under Learning Resources, we can launch demos. Some are screen-based. Here's an example of data storage, screen-based example, and some are script-based. And the script-based ones will launch the Cosmos script runner. And this is File Manager's feature demo script. We can also, under tutorials, we can launch videos. And these will take you to the YouTube videos for a particular topic. And we can also see the training slides. And the training slides, there's one slide deck for all of the apps in a particular group. And finally, under the functional screens, these give us quick links to screens that are organized that may cross multiple apps. So, for example, in the Manage Files, most of it's in FM, but we also have TFTP and access for file transfer as well. Some additional script-based resources are accessed from OSK's main menu. These include functional tests, and I'm showing the CFS functional test suite with the FM app test selected. The goal of functional tests are to verify an app's functional requirements. There are also integration tests that verify the integrated system performs as expected. And finally, there are SimSat operational example scripts that demonstrate how to use the system from an operational perspective. From an organizational perspective, functional tests are in an app targets procedure directory, and the integration and ops example scripts are in the SimSat target procedure directory. Note that the test and ops example scripts are still under development and may be incomplete at this time. We are back at the main screen where we can start system-level scripts under the SimSat reference mission label. First, I'm going to launch the functional test suite. This starts the Cosmos test runner. There are currently 3 test suites that group the apps into functional groups. We have the Mission, SimSat Mission Functional Test Suite, the CFS App Test Suite, and the OpenSatKit Functional Test Group. So if I select the CFS group or suite, it then has test groups for Executive Services, Checksum, and File Manager, and I will be continually adding more tests. Next, we can start the integration test, and this starts the Cosmos script runner. And the first thing it does is launch two screens that group all the CFS apps. It has the SimSat mission apps and the OpenSatKit apps. And finally, we can launch the ops example script. And again, this is going to use the Cosmos script runner. And it launches the top level ops example script that will use other scripts in the terms. So this concludes the app intro tutorial, and I hope you found it helpful as we dive into each of the community apps. Thanks for tuning in.